This brings me to a lovely quote that Jennifer James, an anthropologist, once said. Tapestry is that body of assumptions, beliefs, customs, and practices that we accept as foundational. They define who we are. In this time of great change, the tapestry is being torn rapidly and everywhere. And we begin to fall apart, becoming anxious, losing belief in who we are. We look backward. We keep wanting what we used to know that felt comfortable. We become pessimistic about the present and the future because we can't envision a new tapestry. I love this quote because I know right now in Ontario there's lots of discussion about what numeracy is. It's not just Ontario, it's all across Canada, right? And of course we hit it in the States too. And there was a panic that we were not teaching children how to compute. Many parents thought there was only one way to compute. They wanted kids coming home with the drill sheets and the standard algorithms with pages and pages to practice. They had no idea what we were trying to do, so the critics were just fierce. We seem to have waded through that finally in the States, but now I know in Canada it's becoming a big issue. I think a lot of the reason it becomes such a big issue is that people don't deeply have an understanding of what we're trying to accomplish. And as we begin to tear the tapestry of the old and try to envision the new, we're asking teachers to actually teach math in a way that they themselves didn't even experience. So a great deal of professional development is required. It's absolutely critical that we provide it because we need to move into the new century. And we need to prepare children for the growth of our countries to be able to move our countries forward. And if we constantly just go back to the old, wanting to reiterate the old, we are not going to be enabling our children to be successful in the future. I know in the press there's a big hubbub starting about which is more important, procedural or conceptual understanding. And I just want to go on record as saying that this is not the question to be asking. This makes it sound as if there's a dichotomy. There's not a dichotomy, they're both important. The question is, how do we get the fluency established? And you can't get the fluency established unless you're really working on the development of the mathematics. And you don't want to sacrifice the development of mathematics by teaching the procedures without the underpinnings, because then after the early grades, children will never take the advanced courses because they'll see no connection, and those are critical too. So this is not a dichotomy, both are absolutely critical. One more thing I want to say about this trajectory, this learning trajectory before I go on, is that the trajectories that we have used in the past, that many of us as adults may have experienced, was the early part of the landscape where skip counting and repeated addition came in, and then we thought the next thing on the landscape was automatization of the basic facts. And then we said, okay, now when they have the basic facts automatic, we should go to the standard algorithm. That was our trajectory. We left out the whole foundation of the development of the mathematics. Look at this landscape. Look at all the stuff that would have been left out. So it's really, automatization of the basic facts is absolutely critical, but we want to be using the landscape to work on the development of the facts. The fact that the repeated additions can be regrouped is a critical big idea for children. The fact that you can double. So for example, when you're looking at the basic facts, well, 2 times 4 is one children often learn early on. All right, well to do 4 times 4, you're practically done, you just double. 8 times 4 is done, you've doubled. Right? Let's take a look at the relationships here. The commutative property that 3 times 6 is equivalent to 6 times 3 is critical on the landscape. Big idea. You know what? That leaves out almost half of the facts that we thought kids had to memorize with flashcards. Because every fact can be turned around. All right. The 5s is really easy if you know what happens when you do the 10s, because it's only going to be half. So if you know that you can think of 10 8s as the same thing as 8 10s, so therefore the 8 moves over to the 10s column, right? All right, then 5 times is just half of it. Well, if you use the 5 times, The 6 times becomes easy because it's just one group more. But you could also, to do the 6 times, think of the 3 times and double. To do the 9 times, it's 1 less than the 10 times. The relationships between the facts, that's the framework. That's what's critical in terms of development. And so the facts become automatic, but we want to ensure that we're building the foundation for algebra as we develop them. So it is not just about moving to skip counting and repeated addition and then going to flashcards and then going to the algorithm. That learning trajectory leaves out the whole foundation of the mathematics. We're just not developing a deep understanding of the mathematics when we go that track.